Okay, 3.4, communicate with algebra. When we're looking at communicating with algebra, we need to know certain definitions. For example, term. A term is an expression formed by the product of numbers and or variables. A coefficient is a number only multiplied by a variable. And finally, a variable is one or more letters with their exponents used to represent numbers. Now, a variable can be varied. For example, we can represent a variable with any number that we choose for it to be. That's why it's called a variable and not just a letter. But it can represent any number, so we can vary it up. So I always tell kids to look at it in terms of variable is a letter that can be any number, whereas a coefficient is a specific number. So an example. Let's look at this 3x squared that we see here. What does this 3x squared mean? Well, this whole thing is called a term. All right, so that whole thing is called a term. Now, on that note, the 3 itself is known as the coefficient. The 3 itself is known as the coefficient. Now, the x squared...
Miss Yarich to the office, Miss Yarich to the office.
The x squared is known as the variable. Okay? So the whole thing is called a term, but each piece has a specific name. The number itself, the coefficient, is a number, and the x squared is known as our variable. And this is going to be important later on when we're looking at like terms. A polynomial is an algebraic expression consisting of one or more terms connected by addition and or subtraction signs. So we can add or subtract terms, and that makes a polynomial. These can be classified as monomial, which means one term, binomial, which means two terms, and trinomial, which means three terms. Now don't forget, folks, these all have to be simplified. You can't have any like terms here because you'd have to collect like terms first before you could classify them. All right, next. The degree of a term is the sum of the exponents on the variables in a term. Example 1. Find the degree of each term. So we have a bunch of terms here, and we want to find the total sum of the exponents on the variables. So we have x squared, the sum for this, there is only one exponent, so the degree is 2. The next one, there is a 1, and then a 1 also on the y as well. Because of the 1 and the 1, that makes this have a degree of 2. Next one, what variable is here? There are no variables here. Therefore, the degree of that number is 0. So think of this number, -5, as a constant number. It constantly is -5. It doesn't change. Because it's a constant and there's no variable, the degree must be 0. It has no change possibility. Here we have x squared y. X squared, and then a y has an exponent 1. What's the degree of this term? That's right, it will be 3. The last one. The degree on m has an exponent 3, n has an exponent 1, and p has an exponent 2, so the degree of this final one is 3 plus 1 plus 2, which makes 6. Okay, let's look at another example. But before we continue, let's talk about the degree of a polynomial. So a degree of a term is different from a degree of a polynomial. The degree of a polynomial is the degree of the highest degree term. For example, fill in the table below. Okay, so we have a table here that we're going to be looking at. And we have some polynomials to look at. And then we're going to also identify the type of polynomial. Ready? Here we go. This type is a binomial. It's a binomial because these two terms are not like, and there are two terms, so that makes it a binomial. This one here is a trinomial because none of these terms are like, so it's simplified, and the answer will be a trinomial, 3 terms. The highest degree term here is 2. So the highest degree term is 5x squared. So we want the term. That's what we're looking here is the highest degree term is 5x squared. The degree of that term is 2. The degree of the polynomial is 2. So basically the degree of this is 2. The degree of this is 1. Which one is higher? This one is higher. And it has a degree of 2. So the whole polynomial has a degree of 2. That's how that works with degree of a polynomial. Let's look at the next one. Looking at each one of these, looking at this one piece first, this has a degree of, that's right, 6. This one has a degree of, now be careful of the y has an exponent 1, so the degree of this term is 7. And the degree of this term is 0. So the highest degree term is going to be x to the 6 and y. That's the highest degree term. The degree of that term is 7. And the degree of the entire polynomial is, that's right, 7. The reason it's 7, folks, is because, again, it's the highest degree of each term in the polynomial. Okay. On to another example. Cheryl works part-time as a ski instructor. She earns $125 for the season, plus $20 for each children's lesson and $30 for each adult lesson that she gives. Write an algebraic expression that describes Cheryl's total earnings for the season. Identify the variables and the coefficient of each term and explain what they mean. So we need to express this in a mathematical equation. So let's start off by saying, okay, Cheryl earns her earnings, E equals. What does she earn? She earns $125 for sure, guaranteed. Plus, she earns $20 for each lesson, so 20 times x, plus $30 for each adult lesson that she gives, so 30y. So x is for the children's, 30 is for the adults, 30y. And we need to identify every variable and every number. So E stands for earnings. 125 stands for her basic fee that she earns regardless if she coaches anyone or not. $20 represents her $20 fee per children's lesson. Okay, so the charge per child. And X is the number of children that she's going to be coaching. 30 represents the charge per adult. And the Y represents the number of adults. So that's what you do when you identify each of the variables. One winter, Cheryl gave 8 children's lessons and 6 adult lessons. What were her total earnings? Well, we take the formula that we got in Part A and get the answer by plugging in the numbers. For example, 125 plus 20 times, how many children did she have? 8. Plus 30 times 6. And that equals $465. So Cheryl earned a total of $465 for the winter season. Okay, well, folks, that's the end of the lesson. Have a numerical day.